Welcome to another topic in chemistry. If you are watching this video as assigned in Killinan's Try3 class, go ahead and start setting up your focus notes page. If you're watching this video for any other reason, welcome. We're going to talk about the titration lab procedure today, and I'll actually show you an example. This is assuming you already kind of know a little bit about what titrations are and what kind of data you need to get. And then this will just show you what to do if you needed to set up an actual titration and take data. So our essential question we're answering this is, what are the key steps to a perfect titration? And then I'm going to try to show you a perfect titration also, in addition to getting those key steps. So knowing what they are and seeing them. Pause the video if you need more time to set up your focus notes. When you're ready, let's go. So I'm going to actually exit my PowerPoint and show you a video of a titration setup. So you'll see that I've got some beakers. I have a dropper of my indicator. I have two burettes. This is my acid. This is my base. And I've got it on a ring stand. This is a burette clamp, a DI bottle. I've got my data sheet, a waste beaker, and then some white paper to see that light pink endpoint. So let's get started and show what's going on. So the first thing I need to do is I need to set up my two solutions in my burettes so that I can measure them. So I need to fill them. So you don't pour above your head. So I take it down so that I can pour. I pour slowly so that this burette doesn't overfill. So pour, slow, slow, slow. And I just fill it, pretty full. Doesn't matter what level I fill it, because one of the things I'll do first is read the starting volume of my acid. Now this is the same thing. I do my base. I pour in slowly. I take it down so that I'm not pouring above my head. I go slowly so I don't spill. And I get my base burette pretty much set up. All right, so I've got some acid solution. I have some base solution. I'm kind of ready to start getting some data. All right, so I'm going to take my, take my Erlenmeyer flask. Remember, the shape of this allows my sample to stay in the flask instead of splashing out. I'm going to read my volume at eye level so that I don't worry about that meniscus, which is that like curve that when the solution gets stuck to the glass. All right, so I record on my data table my starting volume of acid. So then I'll be able to figure out how much acid I actually put in. I'm going to put the tip down into the flask so that when I open the stopper, it doesn't splash out. And I'm going to let, about 20 milliliters. Doesn't matter the exact amount right now, or it doesn't matter how much I put in because I'll get the exact number from my data table. All right, around 20 milliliters. All right, that looks good. Stop it. Now, I want to rinse the tip of my burette because the little drop that's hanging off the end is part of my data. And if I don't put it in my flask, it's not really part of it. Once again, I get the volume of acid. I read it at eye level. I'm going to 2 decimal places because that's what these burettes allow me to do. So I'm recording 2 decimal places, and now I've got my sample. I'm going to put my drops of indicator in, 2-3 drops into my acid. This is phenolphthalein. My acid happens to be HNO3. And it's clear right now because phenolphthalein is clear in low pHs. Now I'm ready to get started. I want a white piece of paper under my flask so that I can clearly see the light pink as it forms. I'm going to put my tip in my flask. Oh, wait a second. I need the initial volume of base. Otherwise, I'll have no idea how much base I put in when I'm titrating. Okay, reading at eye level, I'm going to 2 decimal places, whatever the allowance is for the burette that you're using. Be as specific as possible, but not more specific. I'm going to put the tip down in the flask so that, again, when I'm rinsing, when I'm adding, nothing splashes out. Everything stays in the Erlenmeyer flask. All right. Okay, let's get a little close up so we can see here. So notice that it turns pink right when I add the base. That means, oh, yep, I have my indicator in there, but it doesn't stay pink because there's not enough OHs to react with the phenolphthalein to stay pink. So notice that I'm swirling constantly. The tip is in the flask, the white piece of paper, so I can clearly see that pink, and I'm waiting for the pink to stay longer when I swirl it. Ooh, so see how that stayed for quite a while? That means I'm close. So look at how slowly I'm opening the stopper. I'm holding the stopper because bases get slippery so that doesn't fall out and I get base everywhere. I'm rinsing the tip, all that little base droplets, getting it into my sample, swirl that up. Remember, the water just adds, let me pause for a second. The water just adds H's and OH's. It doesn't change my moles of base in my sample or when I did the rinse the tip of the acid. So we can add water because it doesn't change the moles of acid or the moles of base. And since that's the ratio I'm looking for, that is allowed. So that's why I'm allowed to add water. Okay, keep going here. So notice I'm getting close, close, close. Look at how long that pink is staying when I swirl. I rinse the tip. I'm going slow. I'm barely opening the stopper. Oh, man. So close, so close. But it's not, it's still clear. So I rinse a little and then notice I'm opening, just look how barely I'm moving it. So I just get a little bit to kind of hang off the end. There it is. There is my beautiful light pink endpoint. Compare it to the background of that white paper. See how light it is? Yay! That is a perfect light pink endpoint for phenolphthalein. Sodium hydroxide is my standard solution. HNO3 is my acid for this example. All right, so now I'm ready to finish my data. The last piece of it then is to read at eye level, and I go to 2 decimal places because that's what these burettes allow. That's the last piece of my data. So then now what I'm able to do is I know I would probably repeat these trials a few times. So then that would give me I would be able to do calculations and figure out the amount subtraction. How much acid did I use for my sample? How much base did I add? I would know the standard solution concentration. So in this case, it would be the molarity of my base so that I could calculate moles of base used, use stoichiometry from the balanced equation to figure out how many moles of acid I used, and then I would take moles divided by liters of acid from my burette, from my lab data, to get my molarity of acid. So that's the idea. So that is the procedure. That's what a titration looks like. So what I want you to do is I want you to pause this video and I want you to think of the stuff that I kept saying over and over and over again, things you kept seeing me do over and over again. What made that a perfect or really good titration? Pause the video, see if you can come up with 6 things before I give them to you. All right, welcome back. So let's see. The order doesn't matter, but here's 6 things that I kept doing over and over again to get that really nice, perfect, good titration. I'm reading the volume at eye level. Because that burette is so skinny, there is something called adhesion between the glass and the water, and that's what produces that meniscus, that curved surface level. And so you want to read at eye level, go to the bottom of that meniscus, and for our burettes, they always go to 2 decimal places. If you were using burettes in a different lab, maybe it wouldn't, but you have to pay attention to what is the ability of your graduations on your burette. In this case, you can read to 1 decimal place, like 21.2, 21.3, 21.4. So we add 1 more decimal place to say, is it right on that line, a little bit past, a little bit above, that kind of thing. Another thing I did is I made a big deal about putting the tip of the burette down into the flask. So when you're rinsing, when you're swirling, when you're adding, none of your sample splashes out or is above or on the outside or the edge. Swirling, right? So I constantly was making sure that the base and the acid were mixing together so that all the particles are evenly mixed so that they're reacting. I use that white background in the lab. Here you can see that the ring stand is actually white. In our lab, I just used a piece of white scratch paper so that I could see that light pink as it formed. I use DI water to rinse the tip of the burette because on the end of the burette, there was base, there was acid, which means there's H's and OH's. And if they're just hanging off of the tip, but they're not in the flask, they're not really part of my reaction, even though my data is saying I added them. So the DI water doesn't mess up my moles of acid or moles of base. It just has H's and OH's, so I can add the water in to rinse that. And then the last thing is that light pink endpoint, as light as possible. If you get too pink, that means you have too many moles of base, which means you'll have in your ratio too many moles of acid. So then that will make your molarity of acid, your answer, too high. So we want that lightest pink possible for this lab because phenolphthalein was our indicator. All right, those are the 6 parts of a good titration. So if you were doing this lab in person, which some of you might be, or if you take AP Chem or another chemistry class, you'll know what you should be doing as you're collecting your data. And that's it. That brings us to the end of our notes for today. So I want you to go back and write COSTA questions for the notes. I know there wasn't a lot of written notes, but you can come up with 3 different questions, a level 1, a level 2, a level 3. Write a summary for today's notes. So generally summarize what makes it a good titration. If you have not done so already, remember there was a neutralization reactions practice assignment. Finish that, submit that. If you have any questions, make sure you're asking. Remember that you had some unit practice problems related to titrations and neutralization reactions. Go back and do those, check your answers, get any help as needed. Otherwise, we'll see you next time. Thanks so much for listening.